Radicals. A radical, also called a root, is the inverse of raising something to a power. Our symbol for a radical is here. The part underneath is called a radicand. It can be a number and or variables. So radicand. The small number up here, the n, is called the index or the root. If you have a square root symbol, you won't see a number here. The square root is so common, it's the one where there is no number. So that would automatically be looking to reverse something to the second power. Otherwise, it will have the index or the root there. We're going to look at simplifying radicals. There are several rules when you start simplifying radicals, but we're just going to work with the first one, which is you cannot leave a perfect power underneath the radical symbol. So if you have a square root, you cannot leave something squared underneath. If you have a cube root, you cannot leave something cubed underneath. And first we'll look at a couple of perfect powers. Simplifying radicals. Let's recall a couple of radicals that we have looked at. We looked at square roots and cube roots when we were factoring. And so first we'll go back to exponents. Let's say we have 5 squared. And remember that is 5 times 5. And the answer is 25. Then we had the question, there is something squared, and we know the answer is 25, but we'd like to know what the x is. So what is it to the second power that equals 25? This is a square root question, and this is our symbol for square root. The 25 would be underneath. And the answer to it is 5. If we did square root of x squared, the radical symbol and the exponent actually will cancel each other out to leave us just x. The radical or root is the inverse of raising something to a power. If we have 2 to the third, remember that would be 2 times 2 times 2, which would give us 8. And the next question is, there is something to the third. We know the answer is 8. We would like to figure out what this is. So we'd like to go backwards and figure out what the x is. This is a cube root question to reverse something to the third power. Your symbol is a radical and it has a little number here, your index or your root. The 8 is underneath and the answer is 2. 2 is what goes times itself 3 times to give you the 8. If we have the cube root of x cubed, the radical symbol and the exponent will cancel each other to leave you just x. We're going to simplify some radicals that are not perfect powers, and we're going to do this by the prime method. The prime method is a good method to actually understand radicals. When you have to do a lot of radicals, it's a little slow, but it's a very good one to start with. So first we will look at square root of 20, and we have to make sure there are no perfect squares under there. See, it's not a perfect square right now, but we have to make sure there are none in it. One way is to break 20 to primes. So we could do 4 times 5, and 4 gives us some 2's. So 20 is the square root of 2 times 2 times 5. And once we have this down, we're doing a square root. So if we find a group of 2 factors, that is a perfect power. it can go outside the radical. One copy can go outside the radical for the group. So here's a group. One copy will go to the outside for that group, and the 5 would stay. This is like taking the square root of 4, which is a plain 2 with no radical symbol. The 5 has to stay underneath because it doesn't have anything to go with it to make a square. This is simplified form. There is no square left under the radical. You would read that as 2 times the square root of 5. Next, we'll look at the square root of 75x to the third. So we will break to primes. For 75, we could do 25 times 3, and 25 will give us 5 times 5, and we have the 3. So we'll rewrite it as a product. 3, 2 5s, and for x cubed, we can write it out. Gives us 3 x's. All right, it is a square root. We did not have a little number here for an index, so automatically a square root. We're going to look for groups of 2 things for a square root. So the 3 has to stay. It does not have a partner to give a square. The 5s, there are 2, so that is a perfect square, square root of 25. So one copy goes to the outside for that group. For the x's, for 2 of them, you have a group. One will go to the outside for that group. The other x has to stay. Now we'll put it back together. And the parts underneath, you have a 3 left and an x left. So you would read this as 5x times the square root of 3x. That is simplified form. Let's look at one more square root, the square root of 200. So we'll first break to primes. So we could do 2 times 100, and 2 is prime, so we'll bring it down. 100, we could do 10 times 10, and 2 is good. 10 we'll do 2 and 5, and 2 and 5. So we'll rewrite it. We have 1, 2, 3 2s, and we have 2 5s. So, square root, we're looking for groups of 2 factors. That would be a square. Here is a square. 1, 2 can go outside for that group. This 2 will have to stay. The 5s also give us a square. So 1 5 can go to the outside for that group. It will multiply by anything that is out there. And the other 2 has to stay. So we have 2 times 5 is 10 on the outside times the square root of 2. That is simplified form. Let's look at a different root. We're going to go the same way and break to primes underneath. This time we're going to do a cube root though. So that means we are going to be looking for groups of 3 factors. The index just tells you how many factors in a group. So we cannot leave any cubes underneath the radical symbol. So we will break to primes. For 40, we could do 4 times 10. And 4 can do 2 times 2. 10 can do 2 times 5. And then we'll do 5 x's. So we're going to put it back under the radical symbol. Make sure that you keep your index. We have 3 2s. 1 5, and 5 x's. Right. This time, we're looking for groups of 3 factors because 3 is our index. So the 2's make a group. This is like cube root of 8. 1 2 will go to the outside for that group. The 5 has to stay. There's only 1 copy. For the x's, for 3 of them, that makes a cube, 1 group. 1 can go to the outside for that group. The other 2 will have to stay. We'll put the radical symbol back with the little 3 for the index. We have a 5 underneath, and we have 2 x's, which would be x squared. So we have 2x times the cube root of 5x squared. That is simplified form. There is no cube underneath the radical symbol. Let's look at one more example. This time we'll do a fifth root. A fifth root of 64x to the third y to the sixth. So 5 is our index. That means groups of 5 copies. So first we'll break to primes. For 64, I think of 8 times 8. And 8s we can keep going with 2 times 4 and 2 times 4. 2 is good. 4 will keep going. So we're going to have a lot of 2s here. 6 2s altogether. So we'll write it out. Keep your index. If you leave it off, you think it's a square root. So we have 6 2s. We have 3 x's. And we have 6 y's. I'm going to have to put the y's right here to make them fit. All right, so we're going to do groups of 5 factors. Perfect fifth powers. So 1, 2 can go outside for this group, so 1, 2 is going to stay. The x's do not have enough to make a group. They do not have 5. They have to stay underneath the radical. 5 of the y's make a group, so 1 y can go outside for that group, and then we will put it back together. So keep your index. We had 1, 2 left over for the 2's. 3 x's, put them back together in exponential form, and 1 y. Now there are no perfect fifth powers under the radical symbol, so it is in simplified form.